so scientists could get just one look at it. They nearly sacrificed the greatest probe in human history. On November 12, 1980, Voyager 1 swept past Saturn at 17 kilometers per second. At that moment, it could have continued along the ecliptic toward Uranus and Neptune, even out to the distant Kuiper belt. But scientists made a bold decision. They used Saturn's gravity to redirect it, sending it toward Titan, the moon wrapped in an orange haze. The cost of that course change was clear. Voyager 1 left the plane of the ecliptic and headed off into the endless void. Even more ironic, that brief glimpse revealed almost nothing. What secrets is Titan hiding that made humanity pay such a price? And how did it rise above more than 200 moons to earn the title King of Moons? The story begins more than 300 years ago. In 1655, Dutch astronomer Christian Huygens built his own telescope and spotted Titan for the first time. It is the largest of Saturn's 146 known moons, with a diameter of 5,150 kilometers. That makes it bigger than our moon, even larger than the planet Mercury, second only to Ganymede among all moons in the solar system. Titan lies about 1.4 billion kilometers from Earth, and its atmosphere is extremely thick. For centuries after its discovery, humanity knew almost nothing about it. Until 1944, American astronomer Gerard Kuiper used spectral analysis to detect the signature of methane in its atmosphere. That discovery went beyond what scientists expected. Normally, a small moon with weak gravity should struggle to hold on to an atmosphere. Our moon is a classic example. Yet Titan not only kept its atmosphere, it is even denser than Earth's. Scientists began to suspect that something extraordinary was hidden beneath that thick haze. Then in 2004, the Saturn probe Cassini made its first flyby of Titan. Using radar, it discovered lakes of various sizes across the surface. Those lakes sparked excitement among scientists worldwide. Cassini also carried a lander built specifically for Titan called Huygens. In late 2004, it separated from Cassini about 4 million kilometers from Saturn. After a 20-day journey, it successfully landed on Titan's surface in January 2005. It remains the only probe ever to land on a moon other than our own. After landing, humanity finally saw Titan's true landscape. The ground was covered in smooth, rounded pebbles, clearly shaped by flowing liquid over long periods, confirming signs of river activity. Unfortunately, because of limited power, Huygens lost contact with Earth 72 minutes after landing and remained there permanently. After that, Cassini handled all follow-up observations. From 2004 to 2017, it flew past Titan 127 times, collecting a wealth of valuable data to prevent a future accidental impact that could contaminate a potentially habitable environment. Scientists commanded Cassini to deliberately end its mission. On September 15, 2017, engineers skillfully used Titan's gravity to send it precisely into Saturn's atmosphere. As friction built up, heat intensified rapidly, and surface temperatures surged within minutes. Some delicate core components failed first. It fired its thrusters to resist tumbling, its entire structure shaking violently. Even so, it kept its antenna pointed toward Earth, transmitting its final signal. In the end, under extreme heat and pressure, Cassini broke apart into fragments, like a meteor streaking downward, becoming part of Saturn forever. The data Cassini returned at the cost of its mission helped us assemble a full portrait of this king of moons. Titan is tidally locked, with surface temperatures around -179 degrees Celsius. Its rotation period matches its orbital period. If you stood on its surface, Saturn would appear almost motionless in the sky. Titan's gravity is far weaker than Earth's, only about 1/7 as strong. A person who weighs 60 kilograms on Earth would weigh about 8 kilograms there. A light jump could send you more than 3 meters high. Scientists once believed it was made half of water ice and half of rock, but recent radio measurements suggest it may contain a liquid metallic core. Its interior far more complex than once imagined. Although smaller than Earth, Titan has a remarkably thick atmosphere, with surface pressure about 1.5 times that of Earth. It extends outward extensively, protected by Saturn's magnetic field, so the solar wind has not stripped it away, stretching hundreds of kilometers above the surface, far beyond the reach of Earth's atmosphere. Ultraviolet light high above breaks apart molecules and creates trace hydrocarbons, giving Titan its distinctive orange glow. Its weather system is strikingly similar to Earth's, yet completely different. Clouds are made of methane and it rains methane. Rivers and lakes flow with liquid methane and ethane. These liquid lakes come in many shapes. The largest Kraken mare covers about 400,000 square kilometers. Scientists believe strong currents and whirlpools may exist in its central channels. Ontario's Lacus near the South Pole is relatively shallow, only about 40 centimeters deep in some areas with smooth dark shorelines and visible river deltas carved by flowing liquid. Although more than 50 lakes have been identified, we have not yet explored beneath their surfaces, and no signs of life have been found. If life exists on Mars or Europa, it is most likely water-based, but Titan's liquid methane environment could potentially give rise to methane-based life built on hydrocarbons. Such organisms would treat methane as water and ethane as nourishment, producing compounds like acetylene through metabolism. If that is true, it would completely redefine how we understand life. To test this idea in June 2019, NASA announced plans to develop the Dragonfly mission, powered by a nuclear battery. It will be able to roam Titan's surface for years, taking off and landing at multiple sites like a dragonfly, focusing on dunes, craters and equatorial regions for clues to life. It is currently scheduled to launch in July 2028 aboard a Falcon Heavy rocket. After a 6-year journey through space, it is expected to arrive in 2034. From Voyager 1 changing course, to Cassini bringing its mission to a dramatic close, to Dragonfly preparing for launch, humanity has been exploring this orange moon for more than half a century. It may be the final piece in understanding how life begins. Here there is a thick nitrogen atmosphere, global methane lakes, and complex organic chemistry driven by ultraviolet light. These conditions look remarkably like Earth more than 4 billion years ago. If Dragonfly uncovers even the smallest piece of evidence, it would be one of the most astonishing discoveries in human history.